Topic B, tuples. Now, I'd like you to think of tuples as immutable lists. Yes, there are several differences between tuples and lists, but the main one and the reason tuples exist is that in tuples, once created, the data cannot be changed. Inherently, these properties lead to some distinct use cases compared to lists and some distinct advantages. So here they are. So tuples are better suited for use with heterogeneous or different data types. So that's like, in one tuple, we're going to have a name, surname, but we're going to have age, which is an integer. We're going to have some values that are maybe floats. Now, in the structured data, once a system is reading, the index 0 is the name, index 5 is the salary, you do not want any of these structures changed. And if you do not want anything changed, it's better to use a data type that's immutable than data type that's mutable. Next, tuples actually work better if you're plugging them into a function or outputting them out of the function, or even using them as a key for a dictionary. So in terms of a data type being passed around, tuples generally work better. And you're allowed to do little things with them. Like I said, a function can return a tuple, a dictionary can use it for a key. Now, I have to put this one under quotation marks because tuples are supposed to be faster to iterate through than lists and to do operations with than lists. This is because they generally take less space in memory because of the way Python is written. However, when you actually write programs and try this out, it doesn't always bear out. We're going to do our own little experiment. We're going to see what happens. Finally, they are better for passing around data you do not want changed. This works on small scale and big scales. Like I said, in terms of putting data into functions or dictionaries, they're better. But also in terms of applications, perhaps you're doing telemetry, measurements, sensor data, typically science with Python, you definitely want to store the data in tuples because that way, once created, it is what it is. No one can mess with it. So let's have a look at tuple operations. I'll just take one for instance. Let's say we have two tuples, pets and wild. Pets are cat, dog, and horse. Wild is lion, zebra, and antelope. So you can actually create a third variable and add those two together. You cannot append wild to pets because tuples are immutable. You cannot change them, but you can basically do operations with them. And so long as you're creating a brand new instance of a tuple, then you can add them. Now, when it comes to indexing, it is completely identical to strings. In fact, if this slide looks familiar to you, as it should, we haven't done strings all that long ago, it is because all I did to explain how tuples are indexed was replaced L with T for list into tuples, used round brackets, and we have exactly the same results. So a tuple with numbers 1 through 11 actually squares the numbers 1 through 11. If you want to access the third item, it's T square brackets 2, that's going to be 4. Last item, T negative 1, that's going to be that item there. Next, slicing. Now in slicing, it generally works the same as strings. What you have is a tuple followed by square brackets followed by start index where you start the slice, end index. Of course, the slice does not include the end index followed by a colon and the increment. So one more time to iterate. Start index, the index is at which we start slicing. So the first element is included. Stop index, the index at which we stop slicing. The element in this index is not included. And if there is a blank there, then you go to the end of the tuple. And increment. Increment is how many steps you take as you are slicing through a tuple. Okay, so that covers tuples and their basic operations. Let's now have a look at them in code. In this tutorial, we'll be looking at tuples and some basic operations with tuples. Namely, we're going to create tuples, we're going to create nested or two-dimensional tuples, we're going to access items from both. We're not going to be able to manipulate items because tuples are immutable. Finally, we're going to look at this concept of packing and unpacking tuples. So, first things first, let's create some. We have usually used numbers as an example, and that's fun. So you can easily just rattle off some numbers, and here we go. We have a tuple of numbers. We can have a mixed tuple, so call that tuple M, and M can have, I don't know, let's have a string, an integer, and a float. That's a point. So that's a mixed tuple, and that's a tuple of numbers. So if we were to create a nested or a two-dimensional tuple, that would mean that at least one of the items is sort of another tuple. So let's see, if we call this guy to_dim, and you can think of, let's have like, something like coordinates would be a typical use case. So for example, inside here, you would have a tuple with 2, 3, and another tuple with basically pairs of numbers. And if you run into tuples, this would be probably one of the more common use cases, a list of coordinates. And now let's play around with accessing these. So if I run this program, nothing should happen. There's no printing going on. So let's say we want to access that item. Now that's 0, 1, 2. So if we simply print M2, that should give us 2.678, and it does. But now let's play around with this two-dimensional tuple. To_dim. Sounds kind of funny. So let's say we want to access that 7. Well, that would be item 0, 1, 2. So item 2 is going to be both of these. In fact, I'm just going to fill that out first so you see what gets printed, 7, 2. And then you're looking at index 0, 1. So if you want to get a 7, you would basically do a 0, and then you'd get the 7. And if you wanted the 2, you would do the 1. So that's how you access nested or two-dimensional tuples. So finally, you have this concept of packing and unpacking. So packing tuple. You can actually create this just by running a sequence of values without any brackets. So we can say 2, 5, space. That'll do. We can even print packing tuple. Run it. 2, 5, space. Now, unpacking is where things begin to be a bit of fun. So let's just say A, B, C. You have 3 variables, and they are equal to the packing tuple. Control-Alt-L, auto formats it. Let's run this. So this is valid code, and you will see if we print A, B, and C that the value of A has been set to 2, the value of B has been set to 5, and the value of C has been set to space. Packing tuple, I'll print it out at the end, it still remains unchanged. So print A, print B, print C, and we're going to print packing tuple just to demonstrate. So packing tuple remains unchanged, but A gets assigned to the first item, B to the second, and C to the third. And that is tuple packing and unpacking. So just to quickly reiterate, we created some tuples, we created two-dimensional tuples, we accessed values from standard and two-dimensional tuples, and we tackled packing and unpacking. In this video, we continue to look at tuples and operations that we can do with them. So what we're going to be doing is looking at these two tuples of letters and numbers, and then doing the following operations. We're going to be doing slicing, so taking slices, as well as using the iterator to sort of skip past elements. We're going to be using tuples together with for loops and iterating through them. Then we are going to look at a very unique tuple use case, which is functions. In the return statement of a function, you can only return one value, but that value can be a tuple, so that's almost a special hack, allowing functions to return multiple values. This might go a little bit against sort of best practices with function, but nonetheless, it really does add some flexibility. And finally, we're going to look at some common errors that happen with tuples. So let's get started. First up, slicing. Let's take a slice of the numbers tuple. So we can print numbers slice from what to what. Let's go. Third item, index 2 to the fifth item, which is going to be index 4. So you put 5 because 5 is not included. So let's go. 0, 1, 2. That'll be 3, 4, 5. Let's print it. There you go. 3, 4, 5. Now, let's have fun and try to actually just print out the odd and the even numbers. So just to show you, like let's say you want to count from a particular index value to the end. So let's just print numbers from 1 to the end. See, you start at 2. And if we do comma 2, sorry, not comma 2, if we actually create that second colon, you will print from 1, but you will count every other. 2, 4. So you can, for instance, create 2 tuples. One's going to be even numbers, the other's going to be odd numbers. So even nums, and that could be set to this. We could create odd nums. Now, odd nums can start from 0 because the first item is 1. There you go. So that one can start from 0. It can go to the end and then skip by 2. Just to make sure, we're going to print even numbers, comma, even nums, and do the same for the odd. So let's check this out. Even numbers, odd numbers. Excellent. So iterating with tuples. So let's say you just need a for loop. So you could basically do the same for a letter or a number. So you could say for letter in letters, print letter. And what's interesting is that basically you can do a tuple operation here. So you can multiply that tuple by 2 and you're going to get ABCD, ABCD. In fact, let's say we did an item for item in letters plus numbers, print item, ABCD, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm just showing you to demonstrate that there is a way around the fact that tuples are immutable. You can actually do tuple operations in the place of a variable and just use them like this. So just like with other lists, we can actually say something like this. For num in numbers, you can do a number operation here. So print number, boom, boom. And that would be like the square of that number. Sorry, we used n, didn't we? Let's try that. So that is how to use tuples with for loops. Next, functions. And this is a very, very interesting one. Let me think of a function that we can maybe return 2 values. I don't know. For some reason, let's just come up with a function that returns both area and circumference of a circle. So we can say def area and circumference of circle. Really? That's about as descriptive name as I can come up with. That can take in one parameter, that's a radius. So we're going to need pi here so we can import math, and we can go straight to the return statement right here. And on the return statement, do calculations in basically 2 places. So the first can be the area, first part of the tuple, and that's going to be area of a circle, pi r squared. So there's going to be math dot pi times radius squared. And then the second part of the tuple is circumference, which is 2 pi r, which is going to be 2 times math dot pi times radius. So let's test this out. Print. Thank you, autocomplete. Let's say radius 9. Run it, and there it is. Area, circumference. Function, essentially returning 2 values because we basically pack the values into a tuple. So finally, just a couple things. Common errors. I'm just going to do a couple things that cause error messages. So let's say that for some reason you want to change the first letter in letters into capital A. So you'd say something like that, letters 0 equals to A. Now, this is going to be an error. Tuple does not support item assignment. You can do this with lists, and lists and tuples are so similar, but this is something that tuples cannot do. You cannot even add a letter the way you would to a list. So basically, once tuple is created, that's it. It can't change. Letters plus equals to E is a letter that's missing. That is also going to cause an error. Can only concatenate tuple, not string to tuple. So even though this statement uses the assignment variable, I mean, letters plus equals E basically means equals to letters plus E. This basically boils down to trying to concatenate a tuple and a string, or a tuple and an integer, a tuple and something else, and that does not work. It would work with lists, but not with tuples. So I think that covers everything. So just to recap, we have sliced tuples several different ways. We've performed iteration with tuples. We have played around with functions and made a function that returns two values by the virtue of putting the two values in the tuple. And we looked at two common errors with tuples. In this video, we are going to be conducting an experiment. An experiment of what is faster, tuples or strings, in terms of iterating through and processing numbers. So what we have is a list of squares, basically by which you square number 1, square 2, square 3, all the way up to 10 million. And then we have a tuple of the same value. So just to give you a bit of an insight, I'll just print a segment of both. So 0 to 20. So these would be the first 20 terms of the list, maybe first 20 terms of the tuple. In fact, I'll take a different type of segment. I'll take squares. No, I think it was T-U-P squares. And I'm going to take 5,000 to 5,020. So this will give you an idea. First of all, it takes a little bit of time to create these two, and then takes a bit of time to print those. So as you can see, we very quickly get into gigantic numbers, and you can almost add, another 7, 8 zeros. This gives you an idea what it takes to add up all of these. So what I'm going to do first is import the time library and add up all those values into one single number. So let's do that. So we need to import time. I'm going to use time.clock. For those of you using Macs, you can use time.time. It's going to work the same way. So I'm just going to say tick equals to time.clock. And then we're going to have toc equals to time.clock. And print toc minus tick. So that's going to be time expired. So maybe I'm just going to create a print statement. Actually, time taken. So let's run this operation. We're going to need to iterate through the list of squares. So for num in squares, we are going to create a total, set it to 0. And for num in squares, we're going to say total plus equals num. So we're going to add num to the total. And then time is going to be up. So just for the fun of it, we can print num when the time is up. And we'll figure out how long that took. Now, I imagine it'll be 5-6 seconds at least. We can wait patiently. Alright, that's 1.5 seconds. So most of the time we waited was actually to create these two things. But the time taken to add them all to num is 1.53 seconds. And that is the total that it adds up to. So, I don't know, billions. So let's do the very same thing for the tuple, and we'll see what's quicker. So this will be taken list, and it'll be for num in tup squares. And this will be tuple. And this is not exactly going to bust any myths. Even if lists take less time, it doesn't mean that lists always take less time, but it's always good to experiment and test the conventional wisdom. The conventional wisdom says tuples should be faster. Okay, I did not copy tick. Let's test this again. So what's happened is that lists took that much, tuples took that minus that much, which it still seems that lists were marginally faster. Let's try this again. Remember, tuples should be faster, 1.53 and 1.66. So there you go, very similar. But even though, in theory, tuples take up less memory, should process quicker, the list operation is negligibly quicker than the tuple operation. So, make of that what you will. I hope this yields a bit of insight, at least on how to test how long certain operations take to process. You can basically use the stock minus tick for many different applications.